Question 6.8. The reaction of cyanamide NH2Cl in solid state with dioxygen was carried out in a bomb calorimeter, and delta U was found to be minus 742.7 kilojoule per mole at 298 Kelvin temperature. Calculate enthalpy change for the reaction at 298 Kelvin, and that reaction is given here. We know that the enthalpy change is given by the letter delta H, which is equal to delta U, that is change in internal energy, plus delta N RT, where R is gas constant and T is temperature. But what is value of delta Ng? Delta N is refers to the number of moles of gaseous product minus the number of moles of gaseous reactant. So see, in this reaction there are two compounds which are in gaseous state, that is N2 and CO2, but one reactant, that is O2, in gaseous state. So in this reaction we are going to consider only gaseous compound to find out delta N. So let's write down the solution. I am writing this reaction again. NH2 Cn, that is cyanamide, which is in solid state, plus 3 by 2 O2 in gaseous state, which gives N2 plus CO2 plus H2O in liquid state. Okay, here delta U is given, so delta U is equal to minus 742.7 kilojoule per mole, and temperature T is equal to 298 Kelvin. Okay, we know that value of R, that is gas constant, is equal to 8.314 joule per Kelvin per mole. But note down that here value of delta U is in terms of kilojoule. So let's convert R in form of kilojoules. To convert R into kilojoules, we have to divide that quantity 1000. So this is nothing but 8.314 divided by 1000. Now this unit could be kilojoule per Kelvin per mole. Correct. Then last part, that is, let's find out value of delta Ng. Delta Ng is equal to number of moles of gaseous product. So here two products, N2 and CO2, so moles are 2, minus the number of moles of gaseous reactant. Here only one gaseous reactant, therefore moles of oxygen are 3 by 2, so 2 minus 3 by 2. Okay, this is equal to 1 by 2. Okay, so let's write down the formula. Formula is delta H is equal to delta U plus delta N G R T. Correct. So here I will get R is equal to 0.0081314 kilojoule per Kelvin per mole. Therefore, delta H is equal to delta U is minus 742 0.7 plus, right into bracket, delta Ng is equal to half into 0.008314 into temperature is 298 Kelvin. So into 298. Okay. So after doing this multiplication, I will get second term as 1.2 approximately, and answer comes out to be minus 741.5 kilojoule per mole. Okay, so here I got delta H is equal to minus 741.5 kilojoule per mole. Therefore, enthalpy change for the reaction is minus 741.5 kilojoule per mole. Okay, this is required answer. Thank you.